This is a Cutaway Lightsaber Hilt crafted entirely from 3D printed parts. A combination of aluminum, PLA, TPU, and resin printed parts were used to create this stunning display prop. And I'm going to show you how I built it. Let's go. What's up you guys, my name is Mark and welcome to my channel. I downloaded these files for free off Thingiverse and I'll have a link in the description below so that you can download them too. Due to the limited amount of time that I have to make these videos, I partnered with PCBWay to provide all the 3D printed parts for this build. Along with designing custom PCBs, PCBWay provides 3D printing, injection molding, and CNC machining services. They have a plethora of 3D printed materials to choose from, including aluminum, stainless steel, and titanium. The quoting process is quick and easy, and all their parts always come super well packaged. And I highly recommend that you check them out for yourself. I'll have a link in the description below. After ordering, my parts arrived in about 5 business days. The amount of care they take when packaging to make sure that none of the parts are damaged in transit is insane. It took me nearly 15 minutes just to get all the pieces out of the packaging. I ordered a total of 31 parts from PCBWay and have them all laid out here. I got a combination of aluminum, PLA, TPU, and resin printed parts. The pieces I ordered in each material type all have great detailing and surface finishes. Plus the resin and TPU parts were already smoothed, which will save me a bunch of time during post-processing. However, the aluminum pieces do have to be sanded. I start by using a 240 grit sanding drum on my Dremel. Once I've sanded all the parts with 240, I move up to 400 and then to 600 grit. Here is the surface finish of some of the pieces after sanding with the Dremel. Next, I move to wet sanding, starting with 1000 and moving all the way up to 3000 grit sandpaper. Once that's complete, I polish all the parts using a buffing wheel. After buffing, here's what they look like, and although they're not perfect, the surface finish is good enough for me. I sand the PLA parts using the same exact process until I get a comparable surface finish. I went back and forth on whether to paint the resin parts or leave them all black. I ended up painting some of them using a variety of Rust-Oleum's spray paints. I painted all the PLA parts but only some of the resin pieces. I also applied a layer of clear coat to all the painted and unpainted plastic parts. Please be sure to paint in a well-ventilated area and wear the proper PPE when spraying. And this is what the components look like after they've all been painted. Now that all the parts are prepped and painted, I can start on the electronics. The electronics for this build are really simple and all you need are basic soldering skills. I start by soldering some 26 gauge wire to both prongs of the switch. I connect a 75 ohm resistor to the positive wire coming from the 3.7 volt battery. I'm using a 75 ohm resistor because I'm using a red LED. If you decide to use a blue or green or some other color LED, your resistor size is going to be different. So you can look up calculators online to help you figure out what resistor size you need. I'll solder the rest of the electronic components during the hilt assembly. I start by putting together what I'll call sub-assemblies. This includes the power manifold, emitter, pommel, and body. The power manifold consists of a semi-transparent plastic tube that accepts 2 hubs. These hubs are glued to each side of the plastic tube. Contact cement is used to connect the 10 manifold pipes to the upper and lower plastic hubs. I cut 10 short pieces of 18 gauge copper wire and bend them using a needle nose pliers. To give the lightsaber an even more realistic appearance, I glue them to the bottom of the manifold using contact cement. Each of these copper wires will later be connected to the pommel. The lower grip that houses the power manifold can be assembled by gluing the individual TPU pieces to the grip body. This is completed for both halves of the lower grip. The emitter is assembled by gluing the cooling fins to the emitter head. The emitter head is inserted and glued into the emitter housing. The cooling fin housing is placed over the cooling fins and glued to the bottom of the emitter housing. To assemble the pommel, a 14mm M2 screw and hex nut are used to connect the belt clip, pommel housing, and power cell. Superglue is used to attach the vent fan to the end of the power cell. The power cell will hold the 3.7 volt battery and micro LiPo charger. The body of the hilt consists of the switch, saber crystal, and a red LED. The pre-wired switch, switch wedge, and lens are glued to the switch housing. The switch housing is glued to the upper grip and the wire tube is used to route the wires from the switch to the bottom of the grip. The crystal mount is glued in place and the wires are routed through the notch on the back of the mount. One of the wires from the switch is soldered to the LED. The other prong of the LED is soldered to a red wire that will later be connected to the battery. The other wire from the switch is extended and will be connected to the negative wire coming from the battery. The main transparent resin crystal is inserted into the 2 crystal holders and is glued to the upper grip on top of the wire tube. Now that the sub-assemblies are complete, they can all be combined together. The emitter is glued to the top of the upper body and the red power button is glued to the switch. The red and black wires coming from the switch are routed through the middle tube of the manifold. The wires are then routed through the top of the pommel and are soldered to the quick connector with the resistor already attached. The transparent tube in the power manifold is glued to the power cell and the lower grip is glued to the pommel housing. The lower grip is glued to the upper grip and the power manifold is pressure fit into the crystal mount. The battery is attached using the quick connector and stored in the power cell. I also store the LiPo charger in the power cell for easy access whenever I need to charge the battery. Now that half of the cutaway hilt is completed, I insert 1/8 inch by 1/16 inch magnets into the recessed holes of the pommel and grips. When doing this, I make sure the polarities of the magnets are oriented in the same direction, otherwise the pieces will repel instead of attract each other. This allows the other half of the grips and pommel to easily come on and off to reveal the internals of the lightsaber. I also printed this hilt stand I found on Thingiverse. I printed the stand in ABS and put it in an acetone vapor bath for about 15 minutes to obtain a nice glossy finish. The stand turned out great and it will work perfectly for displaying this lightsaber hilt. After that, everything is completed and here is the final product. Thank you guys so much for watching. If you enjoyed this video, please give it a like and consider subscribing to my channel for more content. I'll see you next time and stay classy.